Well, after I recorded that, or after I uploaded that previous video, I realized that I made a mistake in my analysis as to the second example, the guided practice 1B, there on example 1, page 312. Now, it is true that it's an empty set, but I gave you the wrong reason as to why. It was not just simply that was a negative number. It's the fact that we're dealing with a less than an and statement. And so let's work this through and show you why that the answer is truly an empty set, but not the reason that I gave you. So let's go 2c minus 5 is less than negative 3. This is our first case. I'm going to add 5 to both sides. And so then we're left with 2c is less than 2. And so c is less than 1. That's case 1. Now let's look at case 2. I'm going to set it up 2c minus 5, but I'm going to flip the inequality and change the sign of negative 3. So now we got greater than 3. Again, I'm going to add 5 to both sides. So then we got 2c is greater than 8. C is greater, divide by both sides by 2, and so C is greater than 4. Now let's put this on a number line. And so here we got 1, and here we got 4. Let's take our case on the left. Let's see, we'll put this in a different color. All right, so C is less than 1, so I got an open dot right there. And C is less than 1, and so it's headed off in that direction. Then my second case here, C is greater than 4. Again, I would have an open dot, and my graph would be headed in this direction, greater than 4. But because this is a less than inequality, we got to treat this as an and statement. And there's no intersection of this solution set. In other words, there's no overlapping. There's no number that's going to make both statements true. And so for that reason, this is an empty set. All right. We'll see that operate a little bit differently when we deal with greater than statement, absolute value inequalities.